As of August 2025, the PAK-DA Prospective Aviation Complex for Long-Range Aviation program remains in an uncertain and largely non-operational phase. Initially envisioned as a groundbreaking project in Russia's military aviation future, the program is now widely considered to be in a state of indefinite delay. Despite periodic official claims suggesting progress, the lack of verified public evidence or concrete milestones continues to indicate that the project has not produced any airworthy aircraft or reached critical testing phases. The PAK-DA was first conceptualized to create a long-range subsonic bomber using a flying wing designed to reduce visibility on radar. The goal was to engineer an entirely new strategic platform with high survivability, long range, and advanced systems integration. This ambition placed extraordinary demands on the technological and industrial capacity of the Russian aerospace sector. From the early stages of development in the 2000s, through the contract reportedly signed with Tupolev in 2009, official sources stated that full-scale development began sometime between 2013 and 2015. According to public statements by officials and government-affiliated media from 2017 through 2020, the design was completed and component manufacturing for the first prototype started in or around 2020. By that time, the state defense procurement plans outlined expectations for a maiden flight between 2023 and 2025 and full-scale serial production beginning shortly after. Despite those early projections, as of mid-2025, no prototype has appeared in the public domain, and there is no confirmed information on successful ground or flight testing. The absence of photographs, open-source data, satellite verification, official documentation, or independent verification from credible defense sources suggests the project has not advanced to the prototyping or flight stage. Multiple internal factors have contributed to the delays. The first and most critical is the high complexity of the project. Designing a flying wing airframe with reduced radar and thermal signatures requires extremely precise engineering, new manufacturing techniques, and specialized materials. Such work demands ultra-fine tolerances, complex internal structure management, and a high level of integration across all aircraft systems. These requirements go far beyond traditional aviation development and demand significant investment in modern facilities and technical expertise. The engine development remains another unsolved challenge. The PAK-DA requires a new engine specifically optimized for subsonic long-endurance performance. It must operate quietly, emit reduced infrared signatures, and integrate seamlessly into a blended airframe. As of 2025, there are no verified reports of an engine that meets these criteria being tested, integrated, or demonstrated on any testbed platform. Without a dedicated and flight-tested engine, no airframe can proceed to functional tests, which further stalls progress. Russia's domestic industrial base also faces infrastructure limitations that severely impact the program. The aerospace manufacturing environment involves hundreds of specialized subcontractors, each contributing highly specific parts, software, and systems. Since 2022, widespread disruption to the supply chain, financial restrictions, and limited access to high-tech tooling and components have put additional strain on critical program pathways. High-precision equipment required for composite shaping, stealth coating application, electronic warfare systems, and digital cockpit integration are either outdated or insufficiently available. The national budget has also been under pressure due to ongoing external commitments. As a result, the defense sector has had to reallocate funding towards areas that provide immediate tactical value, leading to a significant slowdown in long-term, high-risk development programs. In this context, the PAK-DA, which requires years of stable investment without near-term results, has faced funding shortfalls that further complicate its timeline. Labor shortages and talent drain are also contributing to the stagnation of the program. The advanced technical nature of next-generation aircraft development requires experienced aerospace engineers, system integrators, and avionics experts. Many professionals have either left the country or shifted to more stable sectors, resulting in a growing skills gap. This situation directly impacts the ability to maintain quality assurance, manage project continuity, and retain deep institutional knowledge across the program's many layers. Another critical issue is the lack of publicly visible milestones. In modern aerospace development, key phases such as wind tunnel tests, full-scale mock-ups, subcomponent testing, engine bench trials, and taxi trials are often acknowledged in state-run media or visible via public procurement documents. The PAK-DA program, however, has shown none of these indicators over the past 3 years. While secrecy is a component of military aviation programs, complete invisibility of activity for such an extended time usually signals internal dysfunction or substantial delays. Furthermore, the project has now exceeded its originally projected development cycle. From concept to first flight, a major new aircraft platform is generally expected to materialize within 10 to 15 years under normal conditions. The PAK-DA has been in formal development for more than 15 years, yet not a single test flight has occurred, nor has a static airframe been confirmed for ground trials. This lack of progress suggests the original timeline was unrealistic or that unforeseen problems have critically undermined the plan. Official sources have also shifted in tone over recent years. Whereas earlier statements described specific progress and projected dates, more recent communications have used vague language such as ongoing research and development or continued work on strategic aviation modernization. This shift indicates uncertainty and a move away from firm commitments, which typically reflects delays or technical complications not being disclosed. Finally, there are signs of institutional deprioritization. Other ongoing efforts in the aviation and defense sector appear to have received more consistent attention and visible results. In contrast, PAK-DA updates have become rare, brief, and often repeat prior claims without presenting new information. This is not consistent with an active and progressing program. In total, the lack of a flying prototype, absence of confirmed engine trials, disrupted industrial base, reduced funding, technological shortfalls, skill gaps, and shifting official rhetoric all point to a project that has not only missed its deadlines but may have entered a phase of deep freeze or quiet shelving. The PAK-DA program as of August 2025 is significantly behind schedule and appears to be functionally stalled. The originally planned timelines are no longer credible, and without a dramatic change in technical capacity, industrial stability, and financial support, the program is unlikely to produce a functional platform in the near future. While officially it remains a declared project, its status in real terms aligns with failure to meet developmental expectations or progress beyond the early design phase.